Hi students, so in this session we are going to discuss about the chemical properties of the carbon compounds. The chemical properties of carbon compound, first we are going to discuss about the combustion reaction, then oxidation, the oxidation of alcohol to the carboxylic acid, that is also we are going to see, then oxidation, after that addition reaction, after that the substitution reaction also we are going to discuss. Now we will see the combustion reaction. Next is the chemical properties of carbon compound. The chemical properties of carbon compound, in this session we are going to discuss the combustion reaction, then the oxidation reaction, addition reaction, after that the substitution reaction. First we will see the combustion reaction. Usually the carbon in all allotropic forms burns in oxygen to give the carbon dioxide gas. See, not only the carbon dioxide gas with heat and light also. For example, first the carbon react with the oxygen on heating to produce carbon dioxide and heat and light. Then second reaction, the methane gas react in the presence of oxygen on heating to produce the carbon dioxide gas and water molecule, then large amount of heat and light. Similarly, in alcohol, there is ethanol in the presence of oxygen on heating to give carbon dioxide, water and heat and light. So all this reaction produce the carbon dioxide gas. So this reaction is called combustion reaction. Usually the saturated compound, you know that what is that saturated and the unsaturated compounds mean. The carbon-carbon single bond compounds are the saturated compound, and the carbon-carbon double bond and the carbon-carbon triple bond compounds are unsaturated compound. Already we seen the previous section we seen. See, the saturated compound usually gives a clean flame, but in the unsaturated compound gives a yellow flame. See, you may observe sometimes that candle light and the LPG light. See, which is look like a bluish flame. LPG light a bluish flame, then the candle light gives a yellowish flame. Why this means? Incombustions of, that is not sufficient of oxygen in the yellow flame, that is not supplying of the sufficient oxygen, but in the clean flame means the sufficient amount of oxygen is supplied. Usually the hydrogen fuels are that they have a high combustion energy. The hydrogen fuels gives a clean flame. Not only the hydrogen flame, LPG flame also, and the kerosene stove also gives a clean flame. See, sometimes you can notice that the bottom of the cooking vessel getting blackened. That it means that the air flows are blocked and fuels getting wasted. So fuels such as coal and petroleum have some amount of the nitrogen and sulfur in them. So their combustion result in the formation of oxides of sulfur and the nitrogen, which are major pollutant in the environment. Sometimes, that is, why do the substances burn with or without a flame? See, you have seen that the candle or LPG in the gas stove burns with a flame. However, you will observe that sometimes the coal or the charcoal gives a glows, just glows red and gives out the heat without a flame. Why means? This is because the flame is only produced when a gaseous substance is burned. When wood or charcoal is ignited, the volatile substances present vaporize and burn with a flame in the beginning. A luminous flame is seen when the atoms of gaseous substance are heated and start to glow. So sometimes they are produce color also, that is the elements in the having the characteristics properties. That is why they produce color. Okay. Then next is the oxidation reaction. See here, the oxidation reaction, already we seen that is addition of oxygen, then the removal of hydrogen. Usually that is the oxidation reaction. Here the oxidation reaction means that alcohol get oxidized to the carboxylic acid. Here the alcohol, in the presence of the alkaline potassium permanganate, on heating it gives a carboxylic acid. See, this is the acetic acid. Then or you can use it the acidified potassium dichromate. Either you can use it the potassium permanganate or the potassium dichromate. It gives, that means it converts to carboxylic acid. Usually the alcohols are first step converts to aldehyde, then further undergoes oxidation process, it gives the carboxylic acid. All the alcohol, this is ethanol. Generally the alcohols are gives aldehyde, then carboxylic acid. Here the substances, usually the substances are capable of adding oxygen to others. The substance is called oxidizing agent. Here the potassium permanganate and the potassium dichromate is the oxidizing agent, or you can tell that is the strong oxidizing agent. Here the oxygen is a starting material. Then the addition reaction. The addition reaction, usually the unsaturated hydrocarbon add some hydrogen in the presence of the nickel catalyst. This is the catalyst. Catalyst means just enhance the rate of reaction, just increase the rate of reaction. Rate of reaction means speed increases. Without catalyst also the reaction proceeds, but the reaction is very slow. That's why we are adding the nickel. Nickel is a catalyst. This adding of this catalyst without any chemical changes, they give a product. That is why we are adding sometimes the catalyst. See here you can use it nickel or palladium or also, that is also a catalyst. You can use it nickel or palladium. PD, the symbol is PD. You can use it, then you will get a saturated, unsaturated to saturated compounds. That is the saturated hydrocarbons. This is unsaturated hydrocarbons. This is a saturated hydrocarbon. Usually the catalysts are the substance that cause the reaction to occur or proceed a different rate without the reaction it's being affected. So this reaction is commonly used in the hydrogenation of the vegetable oil using the nickel catalyst. See, vegetable oils are generally have a long unsaturated hydrocarbon chain, while animal fat have the saturated carbon chain. Okay. See, then next is a substitution reaction. Substitution reaction, usually the saturated hydrocarbon. This is a saturated hydrocarbons are fairly unreactive and are inert in the presence of most reagent. However, in the presence of sunlight, the chlorine is added, the hydrocarbon is very fast reaction. So the chlorine can be replaced by the hydrogen atom one by one. So it is called the substitution reaction, because one type of an atom or group of atom takes place to the another. So number of products are usually formed in the with the higher homologous series of alkanes. Okay, so this is the reaction. Methane react with chlorine in the presence of sunlight. Here removal of one hydrogen. Removal of that is why removal of one hydrogen. See, I'll write the reaction like this: CH3H, then Cl. So what happens mean this HCl goes out. The remaining thing is what? CH3Cl, then HCl. So this is called the substitution reaction. When adding of, suppose if you add some more amount of chlorine, again you will get a CH2Cl2 like this. This reaction is a continuous step. So this is called the substitution reaction. Next we will see the some important carbon compounds like ethanol and ethanoic acid. Now the students will see some activities, that is combustion reaction, how takes place, then the oxidation reaction also we can see some activities. Hi students, now we can do one activity, that is combustion. combustion of fuel. See, this is Bunsen burner. You can see the Bunsen burner, one adjustment is there. That is one in the base, the bottom of the Bunsen burner, one fold is there. You can adjust that fold. You can close that fold, or you can close that fold partially, or you can open the fold. Okay. Now I am going to do one experiment. See, on lighting this, see, just I am going to adjust the Bunsen burner. Look, what is the flame now? It's look like a yellowish flame. Okay. Now just I am going to adjust. See, now the complete yellow. There is no blue flame, blue color in flame, just complete yellow, and smokes also produces. Some smoke also produces. Now I am going to adjust the fold in the bottom of this Bunsen burner. Just I am adjusting this fold. Can you see? Now in this area, light bluish flame, and the upper part, the topper is yellowish. Now again I am going to adjust. See, 70%, nearly 70 to 80% is a bluish flame. Then only the topper bottom is yellowish flame. Now see, this is completely bluish color flame. Why this happened? Why now I am adjusting the fold? It's look like a bluish flame, and partially means yellowish flame. Completely closed this hole means it's only yellowish flame. Why? Because the insufficient of oxygen. Here the hole closes the oxygen. That means the closes the air, so that in combustion of that fuel, that means they have that insufficient of oxygen. The fuel does not completely burn. When supply of the sufficient oxygen, now the flame is clean. Okay. You know that in bottom of the vessel and cooking vessels, in gas stoves produces this bluish type flame. So it did not that blackened. But sometimes in wood fire, that usually, suppose on end of the empty, that is cylinder, that is the empty cylinder, means that like very little amount of gases are present. On that time you can see the flames look like. On that time, see, you can see the smoke here. The smoke is, now they produce large amount of smoke. So this smoke is carbon that is deposited on the vessel. So when adjacent of this fold, you will get a clean flame. Hi students, see, this is ethanol, and this is 5% solution of potassium permanganate. Usually the potassium permanganate you have to keep only the dark bottle, but just I prepared the 5% solution of the potassium permanganate. Just now I prepared. After that I am not going to use this solution, because when exposed in the light, the potassium permanganate will be decomposes. See, the ethanol, and this is a water bath. The water bath contains water. The water is heating. Now just I am going to take this ethanol in this test tube. Then add some drops of the potassium permanganate. Just note down the color of the solution. Just I am adding drops of the potassium permanganate solution. Now the solution look like pink in color. Now I am going to heat this solution. What happens, we'll see. Already the water bath is heated. Heat some time, that few minutes. Then the alcohol react with the using of the potassium permanganate, alkaline potassium permanganate on heating, it converts to the carboxylic acid. So this is called the oxidation reaction. Now can you see the pink color? the pink colors are the intensity is reduced, again on heating completely disappears. So this is the potassium permanganate is a oxidizing agent. You can use the potassium permanganate or the acidified potassium dichromate also you can use it. Both potassium permanganate and potassium dichromate is a strong oxidizing agent. Now see, the pink color is completely disappears. That means the oxidation reaction takes place. It converts to what? The carboxylic acid. Hello student, today we were covered the combustion reaction, that is the chemical properties of some carbon compounds. The combustion reaction also we were discussed. Then addition, substitution reaction we were seeing. What is that catalyst, how they are acting, that is also we were seeing.